So this video is investigating the surface area of a square-based pyramid and the formulas for the surface area of a square-based pyramid. So what I want you to do is look at this net that you have, and these are just flaps. So ignore this part right here and here and here. And I want you to think about a formula for the surface area of this shape. Remember, surface area is adding up all of the areas of each side. So you have all of these different areas. I want you to pause the video and I want you to see if you can find a formula for surface area of the shape. So in all likelihood, you have come up with these two ideas, and what you've probably done is realize that each of these four triangles is exactly the same. And so if you take the area of the triangle, base times height divided by 2, if you just times that by 4, you'll get the area of all four triangles. And you might have even realized that the 4 and the 2 cancel out, and you'll actually just be left with 2 times base times height. Another thing you might have realized is that this, because it's a square-based pyramid, the base and the height are the same. So you might have thought about making this base squared. And so right now you have a formula that probably looks something like surface area is 2 base times height plus base squared. That's really good, except there's one small little problem. And the problem is that this base, that the height is actually used somewhere else. And the height is used in volume. And the height means the height of the entire pyramid. It doesn't mean the height of the triangle. So this dotted line is the height of the triangle. What you have to picture for the pyramid, and I can show you a 3D figure of a pyramid, so if you're confused about this, just talk to me and I can show you what a 3D picture, a 3D shape looks like, and we can talk about it. But picture a line going straight up from the middle of this square, directly vertical from the screen, and then these triangles folding up to meet that line. The height will actually be that from this dot directly up vertically. That height is different from the height of each triangle. So we can't call them both h, because if we call them both h, that's confusing, because in volume h means one thing and in surface area h means something else. So instead we use a different letter, and we use the letter S for slant height, which means the height of the slanted part, or in this case, the height of the triangle. So the surface area of a pyramid is going to be 2bs plus b squared. That's the formula for surface area of a pyramid. So let's look at this a little bit further. So just like with a cone, you have a slant height, and we might be given the slant height or might be given the height. And we've got to figure out how to work between those. So I'm just going to draw you a little diagram. So what I was talking about in the previous screen, the height of the pyramid is actually here, that vertical line. The height of the triangle is actually here. And then this part in blue is the radius. So this part is the radius, and this part we call the slant height, and this is the height. And just like we did with a cone, notice this is a right-angled triangle. Slant height, height, radius. So to work between the two, we can go back and forth. Now the part that's confusing is I've called it radius, but it's not actually a radius because this isn't circular. So I have to change this to something else. The blue is half the distance across the base. So this is actually the base divided by 2. So it makes pyramids a little bit harder because in cones it's called the radius, but in pyramids we can't call it the radius, it's not a circle, and so it's the base divided by 2, but it works the same way. So let's say I'm given height and the base. To get slant height, I just do height squared plus the base divided by 2 and then square. Be careful, you have to do the base divided by 2 first and then square it. And then likewise, if I want to find the height, I do slant squared minus base divided by 2. So those two formulas, again, they're just a slight change to Pythagorean theorem, but that's what you can use to work between slant height and height. So let's look at an example. So it says, what is the volume and surface area? So we'll start with volume because it's the easiest. Base, height, depth divided by 3. And the base is 8, the height is 10, and the base is 8. We're going to divide that by 3. And we'll round to 1 decimal place, so we get 213.3 meters cubed. Surface area, the formula is 2bs plus base squared. So you'll look at the picture and you'll notice that slant height was not given. So you've got to actually find that yourself. And to get slant height, we need to use what we just learned. So the base divided by 2, in this case, will be 8 divided by 2. So slant height is height squared plus base divided by 2 squared. In this case, it'll be 10 squared plus 4 squared. And we'll get 116. And then to get slant height, you need to square root that. And we'll round to 1 decimal place. Remember, if it doesn't work out properly, round it to 1 decimal place. And we'll get 10.8. Now we can substitute that into the formula. So 2 times 8 times 10.8 plus 8 squared. And then we can work out those two pieces. So the first one's 172.8. And the second is 64. And our surface area is 236.8. And the units are going to be meters squared. Again, I know that that's a little bit confusing, so if you have any questions, please ask, and I'm happy to show you the difference between slant height and height if that's confusing to you.